Hello and welcome to Maths with Jacob. This lesson will focus on parallel lines rules. The following diagram represents two parallel lines that are intersected by a line called a transversal. So they're the two parallel lines and that's the transversal. It's called a transversal because it cuts across the two lines. When this situation occurs, there are three important rules regarding the types of angles that are formed. Rule 1. Corresponding angles are equal. So here we have the two parallel lines. They're the transversal there, and I've named 8 angles. Angle D equals angle F. This one equals that one. Angle C equals angle H. This one equals that one. Angle A equals angle E. That one equals that one. And angle B equals angle G. That one equals that one. So those four angles are in the same position as those four angles. See, because if you cut that in half, say you slice that in half with the scissors, it's a piece of paper, they look exactly the same as those. And that's why the angles that are in the same position are equal, and they're called corresponding angles. Rule 2, alternate angles are equal. Angle B equals angle F. That one equals that one. And angle C equals angle E. That one equals that one. Now the alternate angles, easy to remember. Two things you have to remember. Alternate angles are inside the parallel lines, but they're on opposite sides of the transversal. So those two there, C and E, are inside the parallel lines, but on opposite sides of the transversal, and the alternate angles are equal. The co-interior angles are supplementary, and that's rule 3. Angle B plus angle E equals 180. So this one plus that one is 180. And angle C plus angle F is 180. This one plus this one gives you 180. The thing with co-interior angles, they're both inside the parallel lines, but on the same side of the transversal. So those two are on the same side, and those two are on the same side. And when you add them together, you get 180 degrees. And that's why the co-interior angles are supplementary. Let's look at some quick examples. Give a value for each of the letters in the following diagram. We have 140 degrees there, so we can calculate those three letters very easily. Angles on a straight line add up to 180, so that's 40. Which makes that 140, and which makes that 40. So once you've got those four there, using the rules that we saw on the previous slide, we get these values for angle B, D, A, and C. Because we've already worked out those four, and as I said before, the rules we saw on the previous slide allow us to calculate those four. The next one, give a value for each of the letters in the following diagram. Now because that's 150, we can calculate those three very easily. That's 30, that's 150, and that's 30. So after calculating those four, or those three, so when those four angles are in place, that allows us to calculate those four. Okay? For example, angle A is 150. See there? 1, 5, 0. Once we know angle A, okay, we can get angle E. That's also 150. Because they are corresponding angles. Okay? We already have this angle here, that one, so angle H is also 150 because they're corresponding angles. And in a similar manner, when you get B and D, where each of them are 30, okay, you can calculate angle E. Okay, you can calculate angle E without any trouble, because if that's 30, that must be 150 because they're co-interior, and so on. So this video has introduced us to the idea of parallel lines that are cut by a transversal, and we have been introduced to three very important types of angles called corresponding angles, alternate angles, and co-interior angles. And once we know the relationship between those angles, it's quite easy to calculate any other angles that are required.